In these first real world problems, we're going to focus on the empirical rule. And you know you're using the empirical rule because they'll typically draw, a normal curve. In this problem, we're talking about student test scores. So the graph summarizes test scores of 24,000 students. And they tell you that the data is normally distributed with a mean of 81 and standard deviation of 2.5. Now, in this problem, they actually do that for you. They take the 81, they put it on the graph, they take the standard deviation of 2.5 and add it to three deviations and subtract it to three deviations. And what you're really looking for here is you have to understand that between these two deviations is 68, but more importantly in a problem like this is that this is 34 and this is 34. And I'm getting this from the empirical rule. So if you need to brush up on that, please watch the video where I explain the empirical rule and explain where these values come from. All right, so those values are empirical rule values. They are approximations of approximations. So I'm just writing this down from the given information that we had previously when we did definitions and terms. And so what we do now is we say, okay, well, this problem is really about percentages. And so if I were to take a look at this problem, there's 24,000 students. So if I were to turn this into a percentage, you just turn this into a part over whole problem from middle school. And this one's pretty easy to do. This is a half, so this is 0.5. And you do that for each of these. So 16,320 students, we're going to divide that by the fact that there's a total of 24,000. And same thing with the 600. So 600 students divided by 24,000 students. And we're going to go to a calculator, in this case, Desmos. But you could, if you wanted to, use a calculator, handheld. So if I look at Desmos and I type in 12,000 divided by 24,000, of course that is 0.5. So let's do the next one, and you can just change the numerator. Nice thing about Desmos is you can just change the numerator to do the rest of them. So 16,320 students is 0.68. So this is 0.68. And then the last one, 600, I can just come up here and adjust this to 600. So 600 students is coming out to 0.25. And these numbers are coming out exactly to things that we see down here, but these are percentages, right? So, you have to be able to go back and forth. 0.5 is really 50%. So the assignment asks you in this problem to select regions, right? To go to identify the regions under the curve where the data is approximately this much. So, what you would do is you would say, okay, well, it's here, right? So here is 50%. This is the lower 50%. And then also, just to understand that the first question is also here, right? And we learned, again, if you don't understand how I did that, we learned that the mean represents 50%. So either one of these, and if you add up all these numbers, you'll get 50%. So that's the answer to question A. It's either A, B, C, and D, or E, F, and H, right? So this one, you could say regions A, B, C, and D, or E, F, G, and H. Okay, so to do the next one, right? We're looking for something that adds up to 68 or 0.68 or 68%. Well, 68% is it's right here, right? So this only has one valid answer, which would be this region right here is where 68% of the data is. You can't add up anything else to ever get this. And if you go back and look at the definitions and terms, it says between the first two deviations that this would happen. So in this problem, we only have regions D and E. Those are your only valid regions. For the last one, you'll notice that 0.025, which as a percent would be 2.5%, is so close to this region. But if you add these two together, you'll get 2.5. So this right here is 2.5. But this over here, you remember we have two regions that add up to the same amount. Those values, if you add them up, come out to this value. So this one has two answers again. And the reason I say that is if you're taking an adaptive test that allows you to select, you can select either of these answers and it will mark it correct. So that's the first empirical rule problem we've seen. The next one will be more verbal. So let's take a look at that one. So this one, we're looking at fish in a habitat. Biology is heavily statistically oriented. So if you're going to be a biology major, you're going to want to consider taking a statistics class, maybe before you get out of high school if possible. So also doctors and stuff, they heavily rely on statistics. So given a normally distributed data set of 500 observers measuring in a fish habitat, what is the approximate number of observations that fall within one standard deviation? And so you can draw the picture if you want, if the picture helps you. You can draw the normal curve. Some students, this visual helps. Between negative sigma or negative 1 sigma and 1 sigma is always 68% of the data. So what this is really asking you to do is take 500 observations and multiply it times 0.68 and say, well, this is how many observations that were made that would expect to have this information. So you have 500 and then times 0.68, which is how you do a percentage problem. And so 340 of those observations would fall within one standard deviation of the mean. And it's sort of if you don't understand the empirical rule and you don't understand the language, this question can literally say, well, what are you asking? They're asking, what would 500 look like on a normal curve? Forget they're talking about fish. That's the real question. So the next question is, what about 3 deviations from the mean? And so if you know the answer is 99.7, you can use it. But if you need the picture, right, the picture for that, would be, 1, 2, 3, 1, 2, 3. The first one we did was 68. That goes to here. The next one we do is 95%. And then the last one, which goes to the third deviation, is 99.7%. And so if I were to change this problem into like a straightforward question, the question is, what is 99.7% of 500? So you would just take 500. You have to change this answer into because this is a percentage, so you have to change it into a decimal, which would be 0.997. You just divide percentages by 100 to turn them into a decimal. Some students will say, well, why do I need a decimal? You can't actually do math with a percentage. All percentages need to be turned into a decimal in order to complete the mathematical requirements. So in this problem, we're going to have 500 times 0.997, and that comes out to 398.5. So, 400. Let me make sure I look at that closely. 498.5. And so how many observations is it? You could say between 498 and 499, but you can't make half of an observation. So typically they would just truncate this and say 498 observations would be expected between the 3 deviations from the mean. So to sum this up, there are 2 things I think are important. You have to know when you're working with the empirical rule. You know that when they start talking about within deviations or when they start talking about approximating values on a normal curve. You also need to know how percentages work. And keep in mind that a percentage is a decimal that's been multiplied by 100. Okay, so keep that in mind, by 100%. But if you're working with percentages and you actually have to do math with them, you have to take your percentage, right? You have to take your 68% and divide by 100% to convert it into a decimal and then just multiply. Some students get really confused about how this works. If you're trying to do math with a percentage, you multiply. If you're trying to turn something into a percentage, you divide. And if you remember that, it's fairly straightforward.